Dear students, very good morning to you. In the previous lecture, I have explained about adiabatic process, how it will take place, and also we have derived the expression for work done during any adiabatic process. There we have found that the work done depends on the temperature, and during the adiabatic process the temperature is also does not remain constant. Today I will explain another concept which is called as internal energy. Now, let us see what is internal energy of the system. Suppose certain mass of a gas is enclosed in a system. Gas is enclosed. Gas enclosed means we are inserting gas molecules inside it. Gas molecules inside it. For example, say your domestic gas, cooking gas, which is enclosed in a cylinder, gas cylinder, red gas cylinder, there that is filled with methane gas. So there will be molecules in the gas, particles in the gas. These particles will be moving in a different direction, and those are in motion. Because those gas molecules are in continuous motion, they will possess kinetic energy. Each molecule will have its own kinetic energy. Apart from this, these molecules will be under interaction. There will be attraction or repulsion forces between the molecules. So, due to these interactions, also the molecules will have energy which is called as potential energy. So, these kinetic energies and the potential energies possessed by all particles in a gas in a system is called internal energy. So, the total kinetic energy and the potential energy possessed by particles in a gas in a system, say, is called its internal energy. The total kinetic energy of all gas molecules, the total potential energies of all gas molecules present in the system is called its internal energy. Internal energy. So, kinetic energy, how it comes? The molecules, the particles in a gas possess kinetic energy by virtue of their motion. How they get potential energy? They possess potential energy by virtue of interaction between particles, because the gas molecules will be attracting due to van der Waals forces occurred. So as a result, this will produce kinetic energy and the potential energy. And this total energy is called as the internal energy of the mass. So internal energy, therefore internal energy depends on velocity of particles or velocity of particles. How velocity of gas molecule changes? By heating. When we heat the gas, their temperature increases. When the temperature increases, then the velocity of particles increases, and hence their internal energy also increases. So, the internal energy increases with temperature of the gas. With the temperature. As the temperature is increased, internal energy also increases. But internal energy does not constitute the motion of the system as a whole. Suppose if you are carrying gas cylinders in a lorry, while transporting, you will carry gas cylinders. If lorry is moving at a faster rate, then that doesn't mean that the internal energy of gas molecules inside the gas cylinders increases. No, it does not depend on the system, motion of the system as a whole. Therefore, internal energy does not depend on motion of the system, motion of the whole system. It depends only on motion of particles, but not on the motion of the system. Okay. Therefore, if work is done on the system, then what will happen? Its internal energy increases. Whenever certain mass of gas is, whenever certain amount of heat is given to the system, then those molecules will gain heat energy and move faster. When they move faster, their internal energy increases. Therefore, internal energy depends on velocity of particles. And it increases with the temperature. Generally, change in internal energy is equal to N CV into Td. Like this we will calculate. Where N is the number of moles of gas, CV is the specific heat at constant volume, and the dT is the change in temperature. If we increase the temperature, then internal energy also increases. Now, another factor is when work is done on the gas. When work is done on the gas, its internal energy increases. If work is done by the gas, then internal energy decreases. When work is done by the gas, then its internal energy decreases. There will be decrease in internal energy. So, this internal energy is a point function. It It is a state function. Internal energy depends on internal energy depends on initial and final states. Initial and final states of the system, and it does not depend on the path followed by the system. It is a state function. It is a state function. Internal energy. So it is a state function. State function. Initial and final state. Internal energy. It does not. It is not. It is not. It is not a path function. It does not depend on the path followed by the system. Path followed by the system. It depends only on initial and the final states of the system, and it does not depend on the path followed by the system. Whereas work done is a path function. Work done is a path function, but internal energy is a state function. So these are the important aspects in the case of internal energy. Internal energy. Now let us study about reversible and irreversible process. Reversible and irreversible process. So these are the points to be remembered regarding the internal energy. So let's move on to the reversible process. Reversible process. Now, what is meant by we frequently come across this process, reversible and irreversible processes, and let us see about reversible and irreversible process, which is very important for short notes. So, first one is reversible. A thermodynamic process can be reversible when there is no loss of energy due to friction or conduction or convection. The energy of the system remains constant. Whatever may be the energy consumed during the forward process, the same thing has to be recovered during the reverse process. Therefore, a thermodynamic process is reversible. A thermodynamic process. A thermodynamic process is reversible if it can be brought to the initial state through same energy changes in each step. Of the process. Suppose if the process is taking place, a thermodynamic process, T1, V1, and it is taken to the another state, say B, where the pressure is P2, volume is V2. This is called as a forward process. Suppose if the gas expands, then it will absorb certain amount of heat dQ, say. it will absorb certain amount of heat dq during all steps and reaches the final state B. If the same gas can be brought to the initial state and this absorbed heat is released, same amount of heat is released during all these steps and reach the initial state, then the process is reversible. If it do not come to the same state, along this path only, it will absorb heat energy and come to the same state A. Then the process is reversible. If it do not come to the state from state B to A, then the process is irreversible. So there should not be loss of energy during the irreversible process. Therefore, in reversible process, there should not be loss of heat or energy due to friction, conduction or convection. And internal energy does not change during the forward process. If it's loose, if internal energy decreases, and again it will regain during the reverse process. And it must be very slow process. Why the reversible process should be slow? Because there should not be loss of energy due to friction or conduction or convection. If the process occurs quickly, then temperature increases enormously so that there may be loss of heat energy. And another one is, say, melting of ice. Seebeck effect, are reversible. So, this is about reversible process. In the case of irreversible process, if a thermodynamic process is irreversible if it cannot be brought to the initial state through same steps, same energy changes. If the process cannot be bring back to the initial state, then the process is called as irreversible process. In the case of irreversible process, in irreversible process, there will be loss of heat. There will be loss of heat due to friction, conduction, or convection. As the heat is lost, which cannot be recovered, Here, that energy can be recovered, even if it is lost. Next one is internal energy changes, and it is a quick process, so that there will be loss of energy. And example is when the system is when current is passing, joule heat is example of irreversible process. Free expansion of gas, is also example of irreversible process. Suppose if you leave the gas in this room, it will expand and go outwards when it is heated. Suppose if this is cool, then outer gas will not enter into the system. Similarly, Joule's heat, when a current is passed through a resistor, or any metallic wire, heat is produced. But if we heat the wire, then current will not be produced. So these are the basic differences between the reversible and irreversible process.